Hello children, greetings of the day. In last lecture we had discussed about errors in measurement and today is the part measurement. There are two measuring instruments in our syllabus. One is vernier caliper, other is screw gauge. Both are used to measure distances. So in today's session we will see how distances are measured with the help of these instruments and how error is calculated. These two are very important from examination point of view also. Every year we get at least one or two questions based on these instruments. तो शुरू कर दें.
Here comes the vernier calipers. As you can see the diagram, this is vernier caliper. If you have done experiments at your school, you must be familiar to this instrument. This is vernier caliper. Now I am labeling the caliper so that you can recognize all its part. Number 1 is jaw. These are the jaws used to measure external dimension of an object. Number 2 is also the jaw. This is used to measure internal diameter of a beaker. Now is number 4, which is the main scale or primary scale. This is identical to your measuring scale that we use in your schools. 5 is nothing, it is primary scale only, but here the readings are in inches. Number 3 is, it is a strip which is used to measure depth of a beaker. 6 is vernier scale. So this is how a vernier caliper looks like. Now let us see how least count is calculated and measurement is made with the help of vernier caliper. This is least count. What is least count? It is the smallest value that can be measured with help of an instrument or maximum error that can occur with the instrument. Let us consider this is our measuring scale, the same scale as you use in your schools. This is calibration 5 here, it is 6 here, and between these two 10 divisions are there. What if an object for which we have to write the length comes up to this point? What would you write its dimension? It would be 5 point. Now if you count these small calibrations, this comes 5.3. After 5.3, because it is not exactly at 5.3, this is lying between 3rd and 4th division. So after 5.3, now you have to write using mental manipulation. So someone may write this as 5.32, some other one may write as 5.33 or 5.36 like. Can anyone write less than 5.3 value? 5.3 value, or can anyone write more than 5.4? No, this is not possible because we can see directly here that it is lying beyond 5.3 and before 5.4. So no one would write the value less than 5.3 or more than 5.4. It has to be between 5.3 and 5.4. So if an error is there, it has to be between these two values, between 5.3 to 5.4. This is what least count is. Least count is, it is this difference from 5.3 to 5.4, that is 0.1 centimeter. So this is the maximum error which is possible with the instrument, and also this is the minimum value which can be measured, because you can see the minimum calibration is of 0.1 centimeter. So the smallest length that can be measured with the help of this instrument is 0.1 centimeter. This is called least count. Now let us see how is least count calculated in case of a vernier caliper. The formula we use is least count is equal to 1 main scale division minus 1 vernier scale division. Now as you can see, I have taken here the enlarged view. 10 vernier scale division is coinciding with 9 main scale divisions. So if you do the calculation, 10 vernier scale division is coinciding with 9 main scale division. Therefore, 1 vernier scale division would be 9 upon 10 MSD. If you substitute this value here, we would get 1 MSD minus 9 upon 10 MSD. That is equal to 1 by 10 MSD. Now what is 1 by 10 MSD? 1 MSD, as we can see directly, this is 1 by 10 centimeter or 1 millimeter. So it will come out as 1 by 10 millimeter we can write, or either it will be 1 by 100 centimeter. This is least count of a vernier caliper. Now let us come to zero error. How is zero error calculated? How is zero error checked in case of a vernier caliper? Ideally, what should happen that if no object is placed between the jaws, if this is main scale and this is vernier scale, so 0 of vernier scale should coincide with main scale 0. It is the ideal case. If there is no zero error in instrument, then 0 of vernier scale should coincide with main scale 0 when there is no object placed between the jaws and the jaws are firmly closed. So this is the ideal case where zero error is not there in the instrument. If vernier scale 0 is right to main scale 0, then it is called positive zero error. And of course, if it is left to main scale 0, then it is called negative error. And if a positive or a negative error is there, then it has to be corrected in final measurement. So if positive error is there, it has to be subtracted, and negative error to be added. This is how correction is made for zero error. So first we have to check least count of instrument and then zero error, whether it is there or not. And if it is there, what is the value? So now we have to check. First we have checked whether zero error is positive or negative. Now we have to check if zero error is present, then what is its value. So for this we have to see which division on vernier scale. There would be 10 divisions. So which division on vernier scale would exactly coinciding with any division on main scale? As you can see here, let that be the 4th division. So zero error would be 4 into least count. This is how zero error is written. Now I am revising the whole thing. First we have to check whether zero error is present or not. For this you have to see when jaws are firmly closed whether 0 of vernier scale is coinciding with main scale 0 or not. If it is coinciding, there is no zero error. If it is not coinciding, then we have to check whether 0 of vernier scale is lying right to or left to main scale 0. If it is right to main scale 0, then it is said to occur positive zero error. If it is left to main scale 0, then it is called negative zero error. Now after checking this positive or negative error, we have to write the exact value of error. For this we have to check which division is exactly coinciding with any division on main scale. Here in the example I have taken that 4th division is exactly coinciding. So 4 into least count would be the value of zero error. Understood completely? Let us proceed now. This is how measurement is made. Between the jaws, as you can see here, between the jaws the object is placed and then reading is taken. How is it taken? First we have to write main scale reading, then vernier scale reading. These two are to be added to give the total value and then zero correction. So these are the steps we have to follow while taking measurement with the help of a vernier scale. First its least count to be determined, then zero error to be determined. After that measurement is to be made with main scale reading, vernier scale reading, addition of these two, and at the end correction is to be done to get final result. Now with help of one example we can see. Here one illustration I have taken where diameter of a steel ball is measured using a vernier caliper. Different readings are given there. It has divisions of 0.1 centimeter on its main scale. So one main scale division is given there. One main scale division is given 0.1 centimeter. Then it is said 10 division of vernier scale coincide with 9 division on main scale. So first let us calculate least count. It is 10 VSD is equal to 9 MSD. So 1 VSD would be 9 upon 10 MSD. And then least count we can write as 1 minus 9 by 10 MSD. I am using the formula just now I had told about. So this is 1 by 10 main scale division, and 1 main scale division is 0.1 centimeter. So this is 0.01 centimeter. This is least count of our scale. Now 3 measurements are given there and 0 error is also there. Now see, I had told you that if 0 error is negative, it has to be added. So in the result we have to make this correction. Now let us see how this result is written. First we have to write main scale reading, then vernier scale reading, and then total. Main scale is 0.5. Its value is given directly in centimeter. So 0.5 centimeter. Vernier scale division is 8. Always vernier scale division has to be multiplied with least count to get the vernier scale reading. So that would be 0.08. Now if you add these two, this will be 0.58. Next reading is 0.5. And this time vernier scale division is 4. So 4 into least count, which is 0.04. If you add these two, this will be 0.54. Third reading is 0.5 centimeter. Again vernier scale reading is 6 into least count, that is 0.06, and the total is 0.56. If we take mean of these three, so mean value will be 0.58 plus 0.54 plus 0.56 upon 3. If you add these three, it would come out as 0.168 upon 3, that is 0.56. Now we have to do the correction, and it is negative error here, so that is to be added. So corrected value will be this plus 0.03, which comes out to be 0.59. This is the answer. So corrected mean diameter is 0.59 centimeter. Which option is correct? Third option. We'll do some more example in our next lecture. The next instrument is screw gauge. As you can see here, this also you must have seen in your laboratories. Here labeling is done. This frame is called U frame. These two are called studs. Between these two studs, object is placed like this. This is the main scale, primary scale, and here the horizontal line you can see, it is also known as, which is written here baseline, this is also written as reference line. It is also known as reference line. And circular scale you can see, with the help of ratchet we have to adjust the value. Now let us come to principle of screw gauge. What is principle of screw gauge? Screw gauge works on the principle of a micrometer screw. Principle of micrometer screw. What does this principle? The principle says that along with rotation, the screw moves in axial direction also. This is how working of a screw is defined. Now let us see pitch. What is pitch? Now let us define pitch. Pitch is the axial movement or the axial advancement. This is the axial advancement of screw in one full rotation. When you are giving the screw a full rotation, how much it advances on axial scale, that is known as pitch. And this value is numerically, its value is equal to, pitch is equal to 1 main scale division also. Sometimes in numerical, directly value of pitch is not provided, but it is given that 1 main scale division is this much. So that has to be taken as pitch. Now again, like any instrument, we have to calculate first the least count of instrument. So any instrument which is based on principle of micrometer screw, the least count is given by formula. Least count is equal to pitch upon number of division on circular scale. This is how least count is defined for this instrument. Now let us come to zero error. How is zero error checked? Again, when no object is placed between the studs, 0 of circular scale should coincide with the reference line. Then it is called there is no zero error. If the instrument is new, it is perfect, so no zero error would be there. In this case, when no object is placed between the studs, 0 of circular scale should coincide with the reference line. But if it is not the case, then we have to check whether 0 is below the reference line or above the reference line. So if 0 is below the reference line, if it is below reference line, 0 error is to be subtracted. What does it mean? What kind of 0 error it is? Absolutely right. This is positive 0 error because it is being subtracted here, and vice versa. If 0 is above the reference line, then it has to be added, and then it is said that negative 0 error is there. Right? So first we have checked what kind of 0 error is there, whether it is negative or it is positive. But we have to write the exact value of 0 error. What is the value? For this we have to see which value is exactly, of course 0 is not coinciding, but which value is coinciding exactly with the reference line. So this value into whatever is on circular scale, so circular scale division when both the studs are closed into least count would give you value of 0 error. Now I am giving you one clue, because sometimes it won't be visible on the scale that whether 0 is lying below or above the reference line. It's a circular scale, so half of the reading would be behind our eye. We have to check with the formula. Here you can see if nth reading is coinciding on circular scale with reference line, so this n, if it is less than capital N by 2. Now what is capital N? This is total number of division on circular scale. So we have to see if the value which is coinciding with reference line is less than total number of division on circular scale upon 2, then 0 error is to be subtracted. If it is less, to be subtracted. And of course, if it is more than n by 2, to be added. It would be added. So now you can check very easily. If the number which is coinciding with reference line is less than n by 2, 0 error to be subtracted. If it is more than n by 2, it is to be added. This is how 0 error is calculated in a screw gauge. Now how is measurement done? Because already we have noted the least count, noted the 0 error. Again I am writing first main scale reading is written. Next is vernier scale reading. Of course here you have to check which division on circular scale is exactly coinciding with the reference line, and that to be multiplied with least count to give vernier scale reading. So it has to be VSD into least count. After that total is done. On addition of these two values you will get the total value, and then zero correction. This is how measurement is done with help of screw gauge. Now let us take one illustration to explain this properly. One screw gauge is there for which it's given for 5 complete rotation of screw, it causes to move a linear distance of 0.25. So what is pitch? First calculate the pitch. Pitch is how much it advances in one full rotation. Here it is saying that for 5 rotation it is advancing by 0.25 centimeter. So for one rotation this value will be 0.25 upon 5, which is 0.05 centimeter. So this is pitch of the scale. Next we have to write the least count. Least count would be, now this is 0.05, which is pitch, already I have calculated, upon total division. Total division is 100. So upon 100 this will give you 5 into 10 to the power minus 4 centimeter. This is least count of the screw gauge given. Now it is asking for thickness of wire. So thickness of wire would be, this is equal to 4 main scale division. So 4 into pitch. As I had already told you that pitch is 1 main scale division. So it has to be multiplied with pitch to give main scale reading. 4 into pitch. This is your main scale reading plus vernier scale reading. Vernier scale reading is given here. 30th division is coinciding. So 30 into least count. If you do the calculation, it would be 4 into pitch. So that will give you 0.20 plus 30 into least count, 0.0150 centimeter, and on addition it will come out as 0.2150. Here it is given negligible zero error, so no need to write the correction. This will be the correct value, 0.2150 centimeter. Which option is this? Second option. Let us see one more illustration. The length of a cylinder is measured with a meter rod having least count 0.1 centimeter. Its diameter is measured with vernier calipers having least count 0.01 centimeter. Given that length is 5 centimeter and radius is 2 centimeter, the percentage error in the calculated value of the volume will be. The options are given here. So let us solve this question. How to calculate percentage error in volume. As we know, volume of a cylinder we can write by V to be equal to pi r square L. So if we have to write percentage error in volume, that will be delta V by V into 100 to be equal to, now this pi is a numeric constant, so it is not to be included while writing relative or percentage error. And then this delta V by V into 100 will be equal to 2 delta R by R multiplied with 100 plus delta L by L multiplied with 100. Now on substituting all the numerical values, as we know that least count is the value that is the maximum error which can occur with a measuring instrument. So let us write the values. Delta R has to be equal to least count of vernier caliper we have to write. That will be 0.01 upon the radius, that is equal to 2 centimeter. Both values are given in centimeter, so no need of conversion, into 100 plus delta L is least count of meter scale, that is given here 0.1. 0.1 and the length is 5 centimeter upon 5 into 100. On calculating this, we will get 1 plus 2%. That is the percentage error in volume. And so the correct option is option number 3. As you can see, in the question it was asking for possible value of percentage error. So whenever it asks for possible value of percentage error or the maximum error that can occur, always we have to use absolute error to be equal to least count of the instrument. So on remembering this, you will be able to solve all the questions where it is asking for the possible or the maximum error, whether it is relative or it is percentage error. With this, our today's session of vernier caliper and screw gauge is complete. In the coming sessions, we are going to solve more examples based on vernier caliper, screw gauge, and also based on calculation of error. So let us look forward for the next session. And as I had said earlier also, that this topic is very important from JEE and NEET point of view. So do practice more and more number of questions from this part. Best of luck for your preparations. Goodbye.